Now we'll have to look at the path of the blood flow. So you should know that the heart is the organ which is required for pumping blood to various parts of the body. The heart is divided into the left side and the right side. From the left side, you have these massive pipes which are taking the blood to different parts of the body. These massive pipes are called arteries, as we mentioned here. These arteries branch out into smaller pipes like this, called as arterioles. They branch out into smaller pipes called arterioles. These arterioles branch out into many very thin pipes called as capillaries, as we mentioned here. So the oxygen rich blood is being transported to the arteries. They are being transported to the arterioles and they are being transported to the capillaries. Here, what happens is it's at the capillaries that we give off oxygen and we take the byproduct, which is carbon dioxide. Okay. Now, and it's only possible with very thin pipes like capillaries. The capillaries are very thin. They are 1/10 or 1/100 the size of the human hair, very thin. That's where with this magic can happen. We can exchange the oxygen and carbon dioxide. Now you have taken carbon dioxide and this blood has become deoxygenated and the capillaries do this work. Now the capillaries start joining together and they become bigger pipes called as venules, and these venules all join together to form slightly bigger pipes called as veins, and these veins come and deposit the deoxygenated blood in the right side of the heart. So you should know this path of the blood. So from the heart, large pipes called arteries are taking, blood vessels called arteries are taking this oxygenated blood, branching out into smaller pipe called as arterioles. These arterioles branch out into smaller pipes called as capillaries. At the tissue level, you have the capillaries. This is where we are exchanging oxygen, carbon dioxide. Now the blood has become deoxygenated. They all start joining back to become slightly bigger pipes called venules. These venules all join together to form bigger pipes called veins, and those veins deposit the deoxygenated blood into the heart. Remember, veins and venules are carrying deoxygenated blood by and large, and arteries and arterioles are carrying oxygenated blood. Okay, I've done this in full detail in the class. Because I don't have time, I'm speeding up the whole process. Now you should know that the left side of the heart dealt with oxygenated blood, right side of the heart dealt with deoxygenated blood. But actually, this heart is actually made up of 4 chambers. We have the upper chambers called as atrium, lower chambers called as ventricles, and because this is on the right side, right atrium, right ventricle, this is called left atrium, left ventricle, and we have distinct valves to this. This here is called tricuspid valve on the right side. This here on the left side is called bicuspid valve. So what happens is the blood from the top of the heart and the bottom of the heart is got in through these massive veins, and what is happening is we are depositing this blood into the right atrium. So the heart is undergoing this contraction, lub and dub. When the lub happens, the first contraction happens, the blood is pushed from the right atrium into the right ventricle through this valve, which is called tricuspid valve. When the dub happens, from the right ventricle, we are pushing out this deoxygenated blood to your lungs. It is going to the lungs, and it's at the lungs where we purify the blood. Now, once the blood is purified here, it is turned oxygenated. We bring back this blood and deposit this into the left ventricle, where again the lub happens. From the left atrium, we move the blood to the left ventricle, and from the left ventricle, we push it out through the body. When the dub happens, it is pushed out to the entire body, and you know the story. It goes through arteries and arterioles and capillaries, and then it gets turned into deoxygenated blood, and then we start coming back again from the body. It is put this cycle keeps going on and on and on, and I've shown you a video also for this in the class. This is just a recap. So This is the working of the entire blood pathway. Do you have any doubts with this?